motion and measurement of distances. Have you traveled by a metro? Do you use it to go to school? Do all these students come to school in the same way? Those of you who live near the school might be coming to school by walking. Some might be using bicycles, rickshaws, scooters, or cars. Those who live far might be coming by bus. If you have to visit some other city, you might travel by car, bus, train, or aeroplane. Scientists travel to the moon in a spacecraft because the moon is very far from the Earth and a spacecraft moves very fast. A particular mode of transport is chosen for every journey. History of transport. Earlier, the human beings moved only on foot. Then, animals were domesticated and they carried men and goods from one place to another. For traveling on water, wooden logs with a hollow cavity in them were used. Gradually, man learned to join logs to make rafts. Wooden planks were also used to make boats. The invention of wheel made land transport easier. Vehicles could be pulled by animals easily. In 19th century, steam engine was invented and it made a big change in the way people traveled. Carriages, rails and boats could all be driven by steam engines. This made travel fast. Instead of steam, modern engines use fuels like petrol, diesel, CNG, etc. Some engines run on electricity. Some very fast trains run on magnets. Human beings always wanted to fly like birds in the sky. Hot air balloons and gliders were the initial attempts to fly. This led to the construction of aeroplanes. We choose the mode of transport depending on the distance we have to travel. How do we find out the distance between two places? Measurement. When you buy shoes for yourself, how do you know which size to buy? The shopkeeper measures your foot. Similarly, a carpenter measures the height and width of a cupboard before making its door. The size of the shoe, the height and width, etc., all involve its measurements of the distance between 2 points. The quantities that can be measured are called physical quantities. Length, weight, volume, time, speed, and temperature are some quantities that can be measured. The physical quantity associated with the measurement of distance between 2 points is called length. Therefore, we can say that measurement is the comparison of an unknown quantity with a known fixed quantity called a unit. It determines the number of times a physical quantity is related to its unit. History of measurement. Earlier, different parts of our bodies were used to measure length. The distance of a step, the width of a finger, and the length of a finger, angul, etc. were some of the widely used units of length in the past. Some other body parts used for measuring length and the names of their corresponding units are given as follows. Distance between the tip of the thumb to the tip of the little finger of a stretched open hand is handspan. Length of foot is a foot. Distance between the end of outstretched arm and chin is a yard. Arm's length from elbow to fingertip is a cubit. Length of a step is a pace. These methods of measuring length were not satisfactory because the length of the arm, foot, and hand span varied from one person to another. Standard units. For uniformity and convenience, a common unit is necessary for the measurement of a physical quantity. For accurate measurement, we need some standard representation of every physical quantity. Such a chosen standard is called a standard unit. A standard unit is a standard measure that has some definite and convenient quantity so that it remains the same under all conditions. In the olden days, the length of a body part of the king was taken as the standard to maintain uniformity. Still, it was not enough. Till the 19th century, various countries used their own system of units. So there were many units for the same physical quantity. This was quite confusing as there was no uniformity all over the world. In 1960, it was recommended that a common system called the International System of Units or SI unit system should be used all over the world. The SI units of all three fundamental units, length, mass, and time, are given below. Quantity, unit, symbol. Length, meter, m. Mass, kilogram, kg. Time, second, s. Nowadays, SI units are followed in almost all countries for all scientific work. However, some other systems of units which are still in use are given below. FPS, foot pound second, CGS, centimeter gram second, MKS, meter kilogram second. SI system of units are based on MKS system, in which unit of length is meter, unit of mass is kilogram, and unit of time is second. Multiples and submultiples of units. The units used for measuring larger quantities are called multiples of fundamental units. For example, the distance between two cities will be a very large value if measured in meters. Therefore, a multiple of meter or a kilometer is used, which is equal to 1000 meters. Here, prefix kilo is used before unit. Similarly, to measure smaller quantities, submultiples of fundamental units are used. For example, the length of a pencil box can be measured in centimeters, which is a 100th part of a meter, or 100 centimeter equals 1 meter. Here, centi is used as prefix. The fundamental units, their multiples and submultiples can all be interconverted. 10 millimeters equals 1 centimeter, 10 centimeters equals 1 decimeter, 10 decimeters equals 1 meter, 1000 meters equals 1 kilometer. A simple way to remember the conversion table is this line. Milli si deci mi deca hi kilo. When you move from left to right, multiply each by 10. When you move from right to left, divide each by 10. 1 millimeter multiplied 10 equals 1 centimeter. 1 centimeter multiplied 10 equals 1 decimeter. 1 decimeter multiplied 10 equals 1 meter. 1 meter multiplied 10 equals 1 decameter. 1 decameter multiplies 10 equals 1 hectometer. 1 hectometer multiplies 10 equals 1 kilometer. Some prefixes used for multiples and submultiples are given in the following table. Prefix, abbreviation, multiple or submultiple. Deci, D, submultiple 1 by 10. Centi, C, submultiple 1 by 100. Milli, M, submultiple 1 by 1000. Kilo, K, multiple 1000. Mega, M, multiple 10 lakh. Giga, G, multiple 100 crores. The commonly used multiple or submultiple units for measuring length, mass and time are given in the following table. Units of length, units of mass, units of time. 1 meter equals 10 decimeters. 1 kilogram equals 1000 grams. 1 minute equals 60 seconds. 1 meter equals 100 centimeters. 1 gram equals 10 decigrams. 1 meter equals 1000 millimeters. 1 gram equals 100 centigrams. 1 hour equals 60 minutes. 1000 meter equals 1 kilometer. 1 gram equals 1000 milligram. 1 day equals 24 hours. 1 ton equals 1000 kilograms. Advantage of SI system. It is universally accepted, standardized set of units. The units do not change with time. Even very small measurements are possible in this system. Interconversion within the system is simple and hence calculations are easy. Measurement of length. Length is measured as the distance between 2 points or objects. The standard unit for measuring length is meter, which is written as m. Thus, the measured value consists of two parts, a numerical value and the unit of measurement used. If the length of a table is 3 meter, it means that the meter length is repeated 3 times. Need for accurate measurements. There are many instruments used to measure length like rulers and measuring tapes. The type of instrument to be used depends on the type of the work and the accuracy that is needed. For example, for measuring small lengths in geometry, we require a 15 centimeter long scale ruler provided in the geometry box. Therefore, we should select an appropriate measuring instrument that suits our requirement. Measuring tape, which is flexible, is used by a tailor to take measurements like that of our chest, waist and other body parts. A meter scale is used by cloth merchant. Stiff steel measuring tape is used by masons, carpenters and civil engineers. We can measure very small lengths by using special instruments like the vernier calipers and the screw gauge. Using meter scale to measure length correctly. it is important that the measurement is done correctly. There are three possible errors which may occur while using a meter scale. Proper placement of scale. If the scale is not placed exactly or correctly along the length being measured, a wrong reading will be obtained. It is therefore necessary that the scale is placed exactly or correctly along the length being measured. Parallax error. An error can occur due to the wrong positioning of the eye while taking the readings. This error is called parallax error. This error can be avoided by placing the object in such a way that the eye is exactly above the point where the measurement is to be taken. In case of damaged zero mark of the scale, the portion of the scale near the zero mark may be worn out. So, in order to measure the length of the object, we usually do not start from zero mark of the scale. In such cases, we should use any other full mark of the scale, and then we must subtract the reading of this full mark from the reading at the initial end. For example, in figure A, the length of the block is 7 minus 1 equals 6 centimeter. Can you find the length of the block in figure B? It is 9 minus 3 equals 6 centimeter. Measuring small thickness. To measure the thickness of a page of your notebook or to measure the thickness of a coin, we cannot use the meter scale directly. Then, how do we measure such small thickness? Measuring the length of a curved line. This can be done using a thread or a divider. Using a thread, the process of measuring the length of a curved line is done by using a thread. Using a divider. While measuring with a divider, separate its legs through a small distance apart, say 2 centimeter, using a ruler. Now place one tip of the divider at one end of the line. Also place the other tip on the line and mark this point. Continue this process and count the number of steps to cover the entire length. If there is any part of the line that is left or uncovered because the tips of the divider has limited reach, measure that remaining part separately. Thus, length of the line equals number of steps multiplies distance between tips of a divider plus length of leftover part. Importance of estimation. The skill to guess the amount of anything without actual measurement is called estimation. Estimation is useful whenever accurate measurements are not necessary. For example, while preparing a dish, if the amounts of salts and spices differ by negligible amount, it does not affect the taste. But if double amount is used, then the dish will be affected. Similarly, in a laboratory, if the amount of a substance varies even a little, then the result of the experiment will be affected. Hence, estimation is important. Rest and motion. Observe a clock carefully. Note the position of its hour and minute hands. Wait for 5 minutes. Again, note the positions of both. Which of the two is at the same position? Which of the two has changed its position? If an object does not show any change in its position with time, it is said to be stationary or at rest. Since the clock did not change its position, it is at rest. It will change its position only if somebody lifts it. If an object changes its position with time, it is said to be moving or in motion. The minute hand changes its position in every 5 minutes. Therefore, it is said to be in motion. Can you name some other stationary objects around you? Now flatten up your palm. Place the clock on the palm. Take a few steps in the room. Are you now in motion? What about the clock? The clock continues to be at the same place on your palm. Is it now at rest or in motion? The clock is at rest with respect to your body, but is in motion with respect to the other objects in the room. Motion is always observed and measured with respect to a frame of reference. When we walk, we change our position with respect to the floor which is at rest. The fan is at rest, whereas its blades are in motion. When you sit in a moving bus, you are at rest with respect to the bus, but are moving with respect to the objects outside. Types of motion. Different objects possess different types of motion. Some objects move in a straight line, whereas some may follow curved paths. The following are the different types of motion. Translatory motion, the motion in which all the parts of an object move through the same distance in a given time, is called translatory motion. For example, a moving car, a ball sliding down a slope, a man walking on the road, etc. Translatory motion is of two types. Rectilinear motion. If an object moves in a straight line, it is said to have a rectilinear motion. An athlete running a 100-meter race, a child going down a slide, or a car moving on a straight road all show a rectilinear motion. Curvilinear motion. If an object moves along a curved path, its motion is called curvilinear. For example, a woman walking on a curved road, a car taking a turn, etc. Circular motion. It is the motion of an object in a circular path around a fixed point called axis. In circular motion, the object reaches the same point from where it starts. For example, the motion of a minute hand of a clock and the motion of a ball tied to a string and whirled around. Rotational motion. When an object undergoes a motion in such a way that its paths cover different distances in a given time, it is said to have rotatory motion. In this motion, the object moves about an axis. The blades of a fan, a spinning top, and a Ferris wheel all have rotatory motion. Random motion. Irregular motion of an object in which the direction of motion is not fixed is called random motion. Its examples include movement of a football player on the field, flirting of a butterfly, motion of an ant, etc. Oscillatory and vibratory motions. When an object moves to and fro about a fixed point, it is said to be in an oscillatory motion. For example, the motion of pendulum of a clock and motion of a swing. In both cases, objects move to and fro from their mean position. Sometimes the whole object does not show to and fro motion. Such a motion is termed vibratory motion. Example, when string of a guitar is plucked, only the string shows to and fro motion. So it is termed vibratory motion. During this motion, a change in shape and size takes place. All musical instruments show this motion. Periodic motion. When the same motion repeats itself after equal intervals of time, we call it a periodic motion. The oscillations of a pendulum, the revolution of the earth around the sun, the movement of hands of a clock, and movement of hands while beating a drum are some examples of periodic motion. Different motions at the same time. Consider the movements of the earth. The earth revolves around the sun in a circular path. So it shows circular motion or revolution. At the same time, the earth also moves on its axis, which is called rotation. So the earth shows two types of motion at the same time, circular and rotational. The earth repeats its motions, revolution and rotation, at fixed intervals of time. So its motion is also termed periodic motion. A spinning top spins on its axis. It also moves in a curved line as a whole. So it shows rotatory as well as curvilinear or circular motion. Similarly, when a person rides a bicycle, the cycle as well as the cyclist show rectilinear motion, translatory motion, but the wheels show rotatory motion as well. When a screw is opened, it shows rectilinear as well as rotatory motion. Uniform and non-uniform motion. Uniform motion. The motion of a particle or an object is said to be uniform if it covers equal distances in equal intervals of time. Look at the given picture. In this, a car is covering equal distances in equal intervals of time. So the car is said to be in uniform motion. Non-uniform motion. The motion of a particle or an object is said to be non-uniform if it covers unequal distances in equal intervals of time. For example, motion of a car on a crowded road and a butterfly moving from one flower to another. Signs in the vicinity. When two vehicles moving in opposite direction cross each other, the speed of each vehicle add up. Thus, the speed of each appears to be more. This is an example of relative motion. Unlike other ants, desert ants don't use pheromone smell trails to navigate between their home and a food source. The pheromones evaporate very quickly in the hot desert. Instead, they use a way to calculate the direct route home. They use sunlight to judge direction. Daylight saving time, DST, or summer time is the practice of advancing clocks during summer months by 1 hour, so the evening daylight lasts an hour longer. This is practiced at many places like Europe, Australia, etc. When a fast moving vehicle moves past a slow moving vehicle, we call it overtaking. This must be done very carefully from a safe distance and from the correct side.